Okay, this lesson is going to be about algebraic proofs. First things first, we need to know how to solve for x, okay, because that's what we're going to be doing through these, what we call two-column proofs. So let's go ahead and go through our warm-up here. First things first, with our solving for x, solving equations, we need to take care of distribution first. So I'm going to distribute this 5 to the x, making it 5x. Then I'm going to distribute the 5 times the positive 2, getting me a plus 10. Everything else here, I'm just going to go ahead and carry down for right now, equals negative 3x minus 6. I like to move my smaller variable first. So here I have a negative 3x. So I'm going to add 3x to both sides. These are gone. This becomes an 8x plus 10. Don't forget, we have a negative 6, so we need to bring the negative 6 down. Now we're going to go ahead and get rid of the constant over by the variable, subtracting it. So on the left, we bring down that 8x. We have negative 6 minus 10 more is a negative 16. Last step, we're going to divide both sides by the coefficient, what's in front of x. And we need to remember we have a negative divided by a positive. We're going to end up with a negative 2. Now, talking about your algebraic proofs, the way that you can organize your algebra work and also justify why did you make that move? What did you do? So we have these things called algebraic proofs of equality, POE. So you'll see me writing POE. These are going to provide us with those justifications. So going through these very quick, guys, most of them are very simple. The addition property of equality, POE. Okay, all this says is, hey, look, I added to both sides. Okay, you've got A equals B, we got A plus C, B plus C. What did you do? You added to both sides, addition property. Subtraction, we're subtracting both sides, subtraction property. Same thing with multiplication. If we're going to multiply by the same thing on both sides, we have multiplication property. If we divide by the same thing, it has to be the same thing, okay? Then we have division. Now, your distributive property is, again, this is going with what we just did in the warm-up. We're going to distribute. We get AB plus AC. Now we get into some other ones. Reflexive property. This is when you have the exact same thing on both sides. Reflection is the same thing on both sides. So think about your reflection. We've got same on both sides. Symmetric. Symmetric, sometimes people don't like 6 equals x, so they're going to switch it to say x equals 6. That is your symmetric property. Here we have a equals b, then b equals a. All we did was switch them. Symmetric switch. That's how I help students remember, symmetric switch. Transitive property of equality. What ends up happening here, let me explain, if a equals b and b equals c, then a equals c. I like to call this cut out the middle man. What we're doing here is we're going to cross off those b's, and we've got a and c, and that's what we end up with. So your transitive, you're going to see the same thing. One ends with one, the next begins with the same thing. We cross it off, we bring the outer two together. Okay, so I'll write in here, cross out the middle man or woman. Your substitution property is what algebra talks as to evaluate a problem, or what a lot of us know as plug in. We have A and B. A can be substituted for B because they're the same thing, and we'll see this in a little bit to help clarify what this looks like in person. So what we're going to do is we're just going to take these several statements and we're just going to identify which one of these properties it's going to be. If we look at here, we have if 5x plus 2 equals 7, then 5x equals 5. Well, what happened between the two of these? We're going to notice what we did was we subtracted 2 from both sides. Okay? So since we subtracted, we have the subtraction POE, property of equality. The next one, if 2x equals 14, then x equals 7. How did you get from one to the other? We took our step of dividing each side by that 2, so we have the division property of equality. If you are amazing at solving for x, these sections right here are going to be really, really easy for you. Here, if x over 2 equals 7, then x equals 14. We don't really cover this a whole lot, but what ends up happening is x divided by 2. To get rid of the 2, we have to do the opposite, inverse operation, and multiply by 2. and we get that 17. So since we multiplied on both sides, we have your multiplication, POE, property of equality. We look at letter D, we see AB equals AB. We have the same thing on both sides, like looking in the mirror. You're going to have your reflexive. There we go, property of equality. Next, if x minus 2 equals 7, then x equals 9. Well, how did we get the 9? What step did we take? We added 2 to both sides, so we have addition, property of equality, POE. On the next one, letter F, we have if 7 equals x, then x equals 7. This is where we switched. Well, we'll just do it on the one. Switch symmetric. Now we take a look, if x equals 4 and x plus y equals 7, then 4 plus y equals 7. Well, what happened here? We knew what x was, so we ended up going in and substituting in. We took out x and we put in that 4. So this is your substitution. That's what the substitution property looks like. Okay. H, if x equals 7 and 7 equals y, okay, we're not switching. Look, we have x equals 7 and 7 equals y. Then x equals y. This is where we see the first equation ends with what the second equation begins with. Bam, cut out that middle man. This is your transitive property. And then I, 2 parentheses x plus 4 equals 2x plus 8. Well, how do we get the 2x plus 8? Look at this. We distributed. So we have our distribution or distributive property. You say distributive or distribution property, we will take it, okay? So that being said, let's go ahead and take a look. When we solve for x, this equation right here, okay, this is what we're looking at. So what we can do is we can use a 2-column proof. And we can take a look at taking these steps in one column, mentioned as our statements, and then we're going to have a column called reasons, and we're going to list the reason why did we write that, okay? Let's look. You're always going to have a given and a proof. Big hint here, statement number 1 is always exactly what the given is. It is verbatim, letter for letter, number for number, symbol for symbol. You're copying the given down here. Hey guys, why did we write this? Your first reason, I don't care what 2-column proof it is, your first reason is always given, always, okay? I'm going to switch colors on this one. First reason is always given. So if I ask you, hey, what do you put in for reason number 1? Write the word given. Now, we're going to prove that x equals negative 2. Well, we already did that in the warm-up. But going through step by step, from statement 1 to statement 2, what did we do to get from statement 1 to statement 2? Well, here I'm seeing that we distributed. So why did we write statement number 2? Under reason number 2, we say we wrote it because this is the distributive property. Now going from statement 2 to statement 3, what did we do here? Right, we moved the x. How did we move the x? We had to add 3x to each side. So why did we write 8x plus 10 equals negative 6? What did we do? We added. So this is your addition property. Moving to statement 4, okay, from 8x plus 10 equals negative 6 to 8x equals negative 16. What did we do? We moved this 10 over. How did we do it? We subtracted 10 from both sides. So why do we write statement 4? Reason is subtraction. And lastly, our last step, what we did was we divided by 8 on both sides. What did we do? We divided. So we have division. That's all we're doing here, okay? One thing we need to make sure, being very, very careful, is right here. Always number your corresponding statements and reasons. My students know when I say corresponding, they say matching. So we have to make sure that we are numbering these. And whenever you have a fully blank two-column proof, we're going to see what happens. You have to make sure that you're writing things in the correct spot. So here, let's take our next problem. We have this problem right here, and they went ahead and wrote statement number 1, always what is given, and our reason. Why did we write that? Make sure you number it. Every single time, given is the first reason. First one in here, write the word given. When we move down here to this next problem, we're looking at, okay, how did we get from here to here? Guys, we actually did not distribute first, did we? Usually I distribute first. But what they decided to do was they added this 1 to both sides, making sure you're adding to the 11 to make the 12. So therefore, since we added to both sides, why did we write this statement? Number 2, number it, addition property. From step 2 to statement 2 to statement 3, we find ourselves, we distributed. So over here, numbering 3, distributive property. Next, how do we get from 3 to 4? Well, that 3x over here is missing. How did I get rid of it? I subtracted 3x from both sides. So reason number 4, subtraction property. Hopefully you're getting the hang of this. Just we're solving for x. What'd you do? I did this. So from 4 to 5, okay, I'm seeing something's happening here. The 12 is missing over here, so I must have subtracted that 12 from both sides. So reason number 5, what I do, I subtracted. Okay, so we have 2 subtractions in a row. That's all right. To get from statement 5 to statement 6, I'm seeing that I divided both sides by 2. So reason number 6, write it number 6, division property. Lastly, what they decided to do, they decided to switch these. Switch symmetric. So number 7, symmetric. I need to give you a forewarning. You will never, ever, even though we are proving x equals -3, you will never, ever, ever write the word prove under a reason. Let's go ahead and put that in here. Very important. People do it all the time. Yes, you're writing the given, but you didn't go from -3 equals x to x equals -3 by proving. No, you did the symmetric property. Okay? The next one's going to be completely blank. You have a couple different options on how you want to approach this. If you would like to just go step by step in the statement column and solve, and then come write your reasons, you can. I've got 2 different problems that I can show you, so I'm going to show you each way. Okay, I'm also going to grab a ruler so I can draw some straight lines underneath the lines that are up here. So the first one, I'm going to go ahead and go step by step. We're going to go statement, reason, statement, reason. Number 1, always number them. Copy down exactly what the given is. X minus 2 equals 3 parentheses x minus 4. Reason 1 is always the word given. I'll not worry about 2 straight of lines here. Step number 2, what are we going to do? Well, I'm going to start solving by doing distribution. So when I distribute this, I'm going to get x minus 2 equals 3 times x is 3x, 3 times -4, -12. And reason number 2, how did I get that? Why did I write that? Because I distributed. Distributive property. And the lines are just there to make it a little more organized. You don't necessarily have to, but it makes it look a lot neater. All right, statement number 3, let's go ahead and take our next step. I'm going to move my variable, okay? So I'm going to subtract this x from both sides. So these are gone. I'm left with a -2 equals, here we've got 2x minus 12. Reason 3, why did I write that down? Because I subtracted. So subtraction. Next step, let's get all the way down to prove that x equals 5. We're not done until x equals 5. So now I need to get this 12 away from that 2x. So I'm going to add 12 to both sides. Negative 2 plus 12 is a positive 10. This will equal 2x. What was my reason for writing 10 equals 2x? Because I just added 12 to both sides, so addition. Property of equality, POE. My next step here, I need to divide both sides by the coefficient, and I get 5 equals x. Why did I put 5 equals x? Because I divided, division property. Now you need to see, we're not done because they want us to prove x equals 5. We have 5 equals x. So we need to switch these around to make it x equals 5. So why did I write x equals 5? Because I applied the switch symmetric property. All right, so we've got one more. So this is one way you can do it. You can do statement, reason, statement, reason. And honestly, I suggest that so you don't accidentally get your reasons out of order. Okay, that's seriously what I'm going to go ahead and suggest there. In fact, you know what? I'm not even going to show you the other way. I don't want you doing the other way because I don't want you messing this up. All right, so the next problem here. Statement number 1 is always what is given to you. 2 minus 5 parentheses x plus 4 equals 72. And as we discussed, reason number 1 is always the word given. When we get down to statement number 2, okay, we'll go ahead and follow what they did. You know, we'll go ahead and get rid of this 2 first. I'm going to subtract this 2 from both sides. I'm going to wind up with a negative 5 parentheses. Do not do 2 steps at a time. Do not. You have to, with 2 column proofs, you have to do 1 step at a time. Here's what we have. Now, what's my reason for writing what I just did? Because I subtracted. Next, let's take our next step. Here, I'm going to distribute the negative 5 to x, make it negative 5x, and distribute that negative 5 to a positive 4. Negative times a positive, negative 20, or minus 20, all equal to 70. What is my reason for writing negative 5x minus 20 equals 70? What did I do? I distributed. Distributive. There we go. If I spelled it wrong, I apologize. Next step. We don't have variables on both sides. We do have constants. I need to get rid of this 20. How am I going to do it? The opposite operation. I'm going to add 20 to both sides. So now we have a negative 5x. The 20 is gone. Equals 90. Why did I write negative 5x equals 90? What did I do? I added 20, so addition. Next, I need to get x by itself. I'm going to divide both sides by negative 5. So these are gone. And x is going to equal negative 18. Why did I write x equals negative 18? What did I just do? I divided by negative 5, so we have our division property. Always go back and check when you have x, make sure they didn't want you to change that out. Guys, that is all that algebraic proofs is. If you've got your algebra down, go step by step. Put your statement, put your reason. Put the next statement, next reason, and that's it.